Hi everyone, welcome to the second video in Quantitative Ability Learning to Learn Math. My name is Tony Xavier, I'm the Chief Learning Officer of IMS. This is a part of a series of videos called Bell the Cat, which is a companion series to my book called Bell the Cat, which is available on Amazon. In the first video, we saw how to solve a quant problem. Irrespective of what topic, what area, what difficulty level, there was a standard process to outline that I've outlined in 5 steps. As to whatever question, these are the 5 steps you should follow as best practices. In this video, we'll look at the second component of getting good at math, which is how to actually learn math. Might sound easier than it seems, but in fact, if I look at, say, the number of students I've dealt with a problem with math, the problem is much more complicated than we think. Now, as usual, there is a story with these sessions. So the story goes back to me in school. The first time I went for math tuition, not necessarily formal tuition, but somebody else apart from my school or in my house I was taught, was in 3rd standard. There was constantly a problem with math. So my mother's friend, had just joined my mother's company, and she used to stay in a convent right opposite to my house. And my mother was like, okay, his maths is a bit poor. Can you help him out? So 3rd standard was the first time, that lady helped me out. And after that, every summer vacation, something or the other, people would be like, either my cousin or somebody else's math is weak, help him out. From 6th standard, I started math tuition. Right? Now, 6th standard, I started math tuition. Back in the day, if you took tuition for something, it means that you're not really good at it. If you're good at something, you don't need to take tuition. But some of us kids would go to tuition in the morning, even say then, okay, people who were reasonably good also would turn up, but those who were turning up, maybe just not necessarily, tuition was not a compulsion, right? It is one of those added things. So I remember this morning as freshly as almost as if it was yesterday. So we're sitting in one small outside room of my teacher. Of this teacher was a old teacher in our school who was retired. Right? So it was a long desk in the veranda. He was sitting. Around him, all of us were sitting. And I remember he just tossed us a problem. He said, hey, solve this geometry problem. All of us looked at the problem and all of us are thinking how to solve it and everything. And suddenly, one kid next to me, he said, sir, I've solved the problem. Now, all of us were shocked for 2 reasons. One, it wasn't much time. None of us even were close to solving the problem. More importantly, that kid, we were in 6th standard, he was in 4th standard. What was a 4th standard kid doing in a 6th standard class? He was one of my classmates' younger brother. He had already finished 4th standard and 5th standard books. So just for fun, he was coming along with his older brother to sit with us, right? Teachers, right? Teachers always get excited when they see a bright young talent. Despite them wanting to be nice towards everybody else, they're curious to see how does this young mind think. So immediately the teacher was like, oh, how did you solve? And that young kid was like, sir, I do a perpendicular. And immediately in my head, I was like, how does he know that you have to draw a perpendicular? Teacher didn't tell us that you have to draw a perpendicular. All of us are sitting with the maths problem and thinking, what formula, what formula, what formula? It was a geometry problem. And he said, you have to draw a perpendicular. It was only much later, after I started teaching, that I realized that among all the students sitting in that room, he was the only one who was actually trying to solve a problem. I'm here, this is what I have. This is where I need to go. How do I build a bridge? How do I solve that problem? Right. So tuitions continued, and I was doing pretty well in school in terms of all the other subjects. Math would be managed somehow or the other, right? And the time came for CAT prep. Now in CAT prep, I was very good at almost all the, this thing like math was, verbal was pretty good. TLR was fairly strong. Verbal was outsized, ability. And in math, I was good with arithmetic and geometry. So back in the day, there were 4 sections and 200 questions. That was the year before. When I took the CAT, it was 3 sections and 50 questions each. 120 minutes, 150 questions, and 50, 50 questions each in 3 sections. Now, my teacher then, my mentor, he said that, see, only 50 questions. You will get at least 15 questions in arithmetic, right? And all the rest of the questions will be from here and there, and geometry also together. You solve at least, these 15 questions and few here and there, you'll easily clear the cutoff. And that was consistently happening in all the mocks also. So I go into the exam and I sit. I see, because back in the day, it was a paper-based test and there was no sectional time limit. You could see the entire paper and you could choose how you allocate your time. The moment I saw the quant paper, I was very, very clear that I'm done for, that it's over. Because there was only one arithmetic question, if I'm not wrong. The rest of the paper was completely full of things I did not like at all. Inequalities in algebra and other stuff, right? So it was just that sort of stuff, and paper didn't work out. I did the other two. Came out of the paper, and later results came out. One of the good things preparing in my time was that you didn't get a score, you didn't get a percentile. You only got a call saying, okay, you have been invited for an interview, please attend so and so, and that's it, right? Now, when the results came out, everybody was like, oh, you might have just missed it, But I knew that I missed it by a mile, because I knew it was not happening. So after that, I had to seriously, I sat and thought, okay, why is this happening? I cannot be what you call selectively dumb, right? It cannot be that I'm good at everything else, but this, and what is the problem? So I figured out that I need to get really good at math. I need to overcome this thing. I need to get better at everything. So I told myself a few things, right? And that most important thing that I told myself was, now imagine I teach you chess, right? Chess has a few rules and you have to play according to those rules. If you know the rules, is it guaranteed that you can play chess? No. You still have to actively use logic, right? So the first thing I wanted to look at it was that it's a logical reasoning exercise. It's not maths. Second thing was, chess has one set of rules. Let's take a other game, any other board game, let's say checkers or Go, and that has another set of rules. So different video games have different sets of rules. So I decided that every area in math is like a game with a different set of rules, right? I need to learn those rules and play that game. And I'm only going to work in that logical reasoning, this thing. And second time round, I ensured that my preparation was geared only to this. I'm not going to look at something from what topic it is, this thing. I'm going to look at, this is the game and these are the rules. Once you know the game and the rules, you have to play the game, right? The second time I did much better than the previous time. Quant was no longer a problem. And I easily, cleared the cutoffs and I got, 4 calls and all of that, right? So the moral of this particular story, by and large, is that first most important thing is everything does not come naturally to everyone, right? We think everybody who's talented is naturally born with that talent. No. Some things come naturally, other things have to be learned, right? More importantly, why we are bad at something and why we are poor at math, I think there are 2-3 reasons for it. That over a period of time, by meeting students and reflecting a bit on how school was and everything, what I understood. First thing was, you were taught for the wrong outcomes. For example, you solve a question mentally. You know the shortcut, you figured it out. And the teacher asks, okay, have you done homework? Yes, ma'am, in my mind, I've solved all the questions. I know how to do it. Will the teacher like it? No. Solving questions was not important. Showing homework was important, right? Showing homework and writing steps. So that was a wrong definition of the outcome, not whether you know how to solve and are you solving using the best methods. Next thing, I feel you were taught through the wrong medium. What do I mean? See, when you need to print something, print is expensive, right? Now, suppose I'm explaining something logically. I will explain that logic in English and it will be written in English, right? So every question, if I'm explaining it logically, maybe I'll use some diagrams, a few equations, but I'll be using more words. More words means more printing. That means more cost. Which is why, because we're taught through books, instead of a lot of words, we are used to reading in maths language. Maths language is what? All symbols and notations. If you're already naturally not comfortable with maths, and I'm teaching maths through maths language, but not natural language, then are you likely to get better at math or become poor at math? You'll become poorer at math, right? So I feel that symbolic language is this thing, it's a thing because we learned through books. And in books, symbolic language is what is there. And if you naturally are not inclined towards math or you don't have natural skill for it, to pick that up won't be easy. The third part is that most important, you don't like math, maybe. I know that from my own experience that, people have strong likes and dislikes. I actually hated f of x. One of the reasons why in that particular, my first attempt, I didn't get through because I saw 3-4 questions with f of x. And for me, if I see f of x, I will leave. I don't know what this thing, but f of x means I hate it. I will leave. Even now I have to tell myself, okay, it's f of x is also a game. It also has a logic. Take a look at it. There is no rational justification for it. It's just one of those things where some of you might see a long passage and feel that I just don't want to read. Yeah. So different people have different likes and dislikes. Right? So don't tell yourself that I am not good at math. Oh my God, I didn't score well in school, so hence I'm this thing. So first, remove all the old narratives about yourself and maths from your head, right? Remove that and then start with a fresh slate. And what is a fresh slate? Rule 1, logic over topic. Look at everything as a logical reasoning exercise. Logic always comes before the actual topic or this thing, and it's not just for math, even for grammar, right? So, for grammar, for example, if you look at people who are very textbook, not aptitude teachers, but textbook teachers, and this thing, if you ask them to teach grammar logically, they can't, because they will be always saying, okay, this is verb, this is auxiliary verb, this is this is that, because they are forced to constantly talk in that language only. That's the only language they know, right? For example, if I take a simple example like modifiers, they'll start teaching like, okay, there is misplaced modifier, there's squinting modifier, there is dangling modifier. Now, technically, so much baggage in your head is useless. And grammar also follows logic first. What does modifier say? Modifying means anything which is talking or modifying something. So, whatever words you are using to describe something or modify something, that word and set of phrase should be next to what you're saying. So, if you're speaking something about me, that part should be next to me, not somewhere away from it. That's it. Now, when is it misplaced? When it's not next to me. When it is dangling, instead of being next to me, it is right at the end of the sentence. When is it squinting? If it is between me and somebody else. Now, do you actually need to teach all of this? No. You need to say logically, if this part is being spoken about this, then it should be close to it. That's all, end of story, right? So, always follow the logic and not the topic, right? Don't get caught in the topic. Next, concept over type. Now, we get caught in, okay, profit loss, upstream problem, downstream problem, escalator, so and so, right? It almost like we get a huge variety and we get caught in. This is a node, which is a concept, and there are so many branches. We get caught in all of these particulars and these branches, right? But escalator problem, this problem, that problem, finally all of those are time, speed, distance problems only, right? Don't get obsessed with types. Because the moment you start getting obsessed with types, that means that you're starting to memorize stuff. Focus on the core concepts. That is more important than the type. Third part, technique over everything else. You might know concepts and everything. But the first video in this series, how to solve a quant problem, that technique is absolutely important, right? So today what we'll do is, I'll take my favorite topic, right? Weighted averages. This is my favorite topic in arithmetic because I feel it's very, very versatile. And we look at concept learning as to how do you actually learn this concept when I say what it means to learn a concept. Second, how do I take the same context and same question and apply in different concept and apply in different contexts in terms of application in the QA section. And the last one, I'll also show you how it can also apply in the DILR section. Not too many problems. So that's what we will do. And then last, I'll close with the approach to math. So let's start with the concept. Now, what is the simple average, right? If I have rice of 80 kgs per kilo, I have rice of 40 kgs per kilo. Simple average is just sum of both of these divided by 2. I have 1 kg of this, 1 kg of divided by 2. So I'll give you an example. In a class, so there is one student who is extremely geeky. All of these are stereotypes because I had to choose from images. So geeky means it's a kid with a computer, right? And he always gets 80. And then there is somebody else who's very, very artistic and this person gets 40. You are exactly in the middle. You are the average student, right? You are exactly between the two. So there is one person who's geeky and then one person who's artsy. And if I'm saying you are the average of the two, right? What will the average be? Average is always 80 plus 40 by 2. One person who's a geek, one person who's into arts or sports, and 80 plus 40 by 2, that is 60. Correct. Now, if you look at a simple average, what is a feature of a simple average? It's always in the middle, and both values, the average, both the values are equidistant from the 2, right? So 80, 40, the average is equidistant from both of them, right? So that's the idea of a simple average. Yep. Now, there is one more person who comes in. That person also always gets an average score of 80. And there is another person on this side, a chef. Let's say that is, 40. So as long as the number of people in each group is the same, right? It's almost like, say, 1 kilo rice at 80, 1 kilo rice at 40. 2 kilo rice at 80, 2 kilos rice at 40. So two students of category A, 2 students of category B. You will continue to remain the average because on both sides of you, the number is the same, right? So 1 kilo, 1 kilo, 2 kilo, 2 kilo, 2 people, 2 people, 3 people, 3 people, right? What happens in a weighted average situation, right? In a weighted average situation, automatically, the weights are not equal. One side is more weighted than the other, right? One side becomes heavier than the other. Now, if I'm looking at one side, the same situation, there is group A with 80 and group B with 40. You are there in the middle with 60. Now, there is one person who comes on this side, additional, but nobody joins the other group. What is going to happen now to the average? Right? If I think of it as like, two political parties. One party has 50 seats, the other party has 50 seats. Right? And we say that, and there are few more results being announced. We say that the number of seats in parliament, 50 votes, other party, will be divided proportionally. Whoever gets more votes, that much proportion more can get. So the moment, say, one party gets one more vote, immediately the power shifts in their side. Similarly, the moment, say, 80 has more people, group of 80, the average also will start moving there, right? So if you have 40 kilos of, 5 kilos of 40 rupees rice and 5 kilos of 80 rupees rice, average will be 60, right? The moment you buy 1 extra kilo of 80 rupees rice, what happens? The average price of the rice you have will go up from the existing average. Why? Because average is 60 and you have bought an additional kg of 80 rupees rice. What happens? Instead of buying that 80 kilos rice, you buy an additional kilo of 40 rupees rice. You've bought something lower than the average, so it goes down, right? So you know that whenever the weights are same, the average remains constant. Whenever one side or the other side, right, is increasing in quantity, average moves towards that quantity, right? Now, if you have one more person, again, it increases. Suppose you have one more person coming in here. The 5 people, here 5 and 4, it average starts moving towards 80. One more person comes in, it starts moving further towards 80, right? So average always tilts towards the heavier group in a weighted average situation. Now, how do we calculate this average? Suppose I say X kilos of rice at A rupees is mixed with Y kilos of rice at B rupees. What is the price per kilo C of the mixture, right? So I'm saying X kilos at A rupees and Y kilos at B rupees. What are they saying? I've mixed all of this. They're asking me of this mixture, what is this price of rice? If you have to price per kilo, what will you do? Total money that you spent divided by total number of kilos. That will give you average price per kilo of the mixture. Total money you spent in A is how much? X kilos of A. So that is X into A. Total at price B is how much? Y kilos at B. So Y into B. That is the total cost you have incurred, divided by total number of kgs is what? X plus y. Now this is nothing but the average price, which is C. Average is always total what you call cost, the total this thing divided by the total number of units. I will explain this a bit in detail later. Now, if you look at this, let's go solving this equation. What happens? Right? X plus x into a plus y plus b into y plus b is equal to x plus y. Now the C can go to the other side, right? What do you get? X into a plus y into b is equal to C into a plus, x plus y. C into x plus y, you get x to y side, one side and y to the other side. What do you get? X into a minus c is equal to y into b minus c, right? So that is, c minus b. So what do you get there? X by y is equal to c minus b by a minus c. Now this is the formula. X by y is equal to c minus b by a minus c. But when you're really trying to understand the math in terms of fundamentally as a concept, to understand as a concept, what does this actually mean? What does this mean? X by y is equal to c minus b by a minus c. This is x, the average of one group. This is y, the average of the other group. So there are x people with an average of A, there are y people with an average of B, right? So it can be x kilos of rice at price A or y kilos of rice at price B, or x number of people who have average score of A and y number of people average score of B. And the resultant average of the whole class is C. Now, x and y, as I said, can be anything. Number of students and the average maths marks so far of them. It can be number of kilos and average price, the price of a kg. It can be number of liters and it can be milk concentration, right? It can be anything. It can be males and females and average work experience. So it's always two quantities and two attributes. What are the quantities? Kilos, liters, number, volume, etc. What are the attributes? Average marks, price of per kilo of rice, milk concentration, work experience, anything is the attribute. Now, if this formula has to become real, what does it say? X by y is equal to c minus b by a minus c is equal to 2. What does that mean? It means that if this is 6 and this is 4, right? This c minus b is 6 and b minus, and this difference is 4. So if x and y are in the ratio 6:4, then this difference from the center is equal to this sequence, that ratio is the same. Now think about it, sir, why is it getting reversed? It is very simple, no? The more the quantity of one side, the average moves closer to that. That means the other quantity goes farther from the average. So if I am twice the other in number, that means the other will be twice as far from the average, right? So essentially what is happening, the more one side is getting heavier, the other side will go that much far. How much far? It will go as far as the number of times this one is heavier, right? So if you look at it this way, if x by y is equal to 2, that means x is 2 times y. Number of people on this side is twice the number of people on that side. Then c minus b, that group, the second group, will be twice as far from the average, right? So if both of us, are here on the same this thing, right? And there are my average weight is A and your average weight is B, right? If say the number of people on my side on a seesaw or whatever is 3 times the number of people on your side, then you will be thrice as far away from the average, right? The heavier this side gets, the farther that side will go. What is the relationship? In direct proportion, right? From here to there, right? This is the most easiest way to understand. Don't understand it in concept of x minus y is equal to c minus b or a minus c. Understand that if this becomes 2 times in this, then that difference is 2 times this difference, right? The ratio of quantities is always equal to the inverse ratio of the distance from the mean, right? In why inverse ratio? Because the reverse side, the ratio is exactly getting reversed here. So in your head, this ratio and just reverse the numbers. Now, for this, how do we calculate? If you want to calculate this average, you know that this is 6 and this is 4. The normal way to calculate using this would be what? You know that 6 by 4. What is that ratio? That ratio becomes 6 by 4 is what? 3 by 2. 3 by 2 is equal to this difference, x minus 40 divided by 80 minus x. Now, technically, sir, why did you do x minus 40 or 80 minus x? What do we know? Average will always lie in the middle. Will average be greater than both? No. Will average be less than both? No. It will be somewhere between the two, not exactly middle, somewhere between the two. So, x will always be, the resultant will always be greater than the smaller one and smaller than the larger one, right? It will always be smaller than the, greater than the larger value, than the smaller value, and smaller than the larger value. It will always be somewhere in the middle. So, it will be always x minus 40 divided by 80 minus x. Think logically, you don't need to remember, is it c minus b, b minus c, or whatever it is, right? And especially if you're calculating, and if you're calculating the ratios, just the difference is also fine. So, from this you can calculate, right? This is one way. There is another way to do it also. Other way to do it is, you're seeing 6:4, this is 3:2 ratio. This gap between 80 and 40, how much is the gap between 80 and 40? 40. This 40 is getting divided in the ratio. If this is 3:2, 40 is getting divided in the ratio 2:3. That's it. It's an easier way of doing it because there is no equation to write. 40 gets divided, whatever is the gap divided, then it gets in the ratio 3:2, right? So, for example, if there are two parties that are contesting, right, and there are 100 seats in parliament or X seats in parliament, right, and that seats get divided in the ratio of the percentage of votes each party has got. So, if the ratio of the votes that the parties have got in the ratio 3:2, these 100 seats also will get divided that way. So, we know that this gap is, so that is in the 3:2 ratio, 3:2 ratio. So, this gap will always get divided in the reverse ratio 2:3. 40 if I need to divide in the ratio 2:3, how does that happen? 40 in the ratio 2:3. 2 by 5 into 40. 2 by 5 into 40, 5 goes 8 times, 8 2s are 16, right? So, this part from 80, it is 16. 80 is the larger value. Average will be smaller than that, less in the smaller value. So, from 80 you subtract 16. This is 2, this is 3. You know that is 3:2. That means this is 2:3. So, from 80 you need to subtract 16 and you will get 64. So, why did you subtract 16? As I said, average lies in the middle, right? Average lies in the middle. This gap gets divided in the ratio 2:3. So, if this is two parts of 40, that means 2 by 5 into 40 is how much? That is 16. So, this is 80. The gap is 16. So, this is 64, right? Now, straight away, you know the other part of this is 16. So, the other part is what? 24. Yeah. So, this by this is equal, this by this is equal to this gap by this gap. The ratio just gets reversed. In your head, the easiest way to remember this, whenever you see this problem, is imagine it like this: x, y, a, b, c. That's it. X by y is equal to this difference by this difference. Only remember it by that. X by y, this by this is equal to this difference by this difference. So, why are you saying only difference, this thing? Just if you need to calculate the ratio, it's only difference. Should you add it? Should you subtract it? What is it? That we'll look at a few problems. You'll come to know. All you know is that average will be in the middle. One value will be greater, one value will be lesser. All you need is the difference. On one side, you will add to get the larger value. On the other side, you will subtract, get the smaller value, right? So, this by this, so just remember it in this pure context that this by this is equal to this gap by this gap, right? So, it's always in the reverse ratio. Just to summarize everything, weighted average problems usually involve an attribute. What is attribute? Prices, weight, income, age, marks, milk percent, alcohol percent. Belonging to two or more different groups, what we've discussed is two groups. There can be male, female, there can be gender, there can be sections, there can be what you call containers. These two groups are mixed in different quantities, X and Y. This can be numbers, weight, volume, liter, whatever. The weighted average, as I said, will always lie somewhere between the two values, right? So, it will be somewhere between the two values of the particular attributes. Higher than one group and lower than the other. Now, to solve this, to really help you understand this, we'll look at a question type called data sufficiency. Now, data sufficiency is not asked on the CAT. but it is no longer asked on the CAT. It was before, long time before. But it's a beautiful question type to understand concepts. Why is it so? Because it just says, do you have the information to answer the question? That's it. You don't need to answer the question. You don't need to, you're acting like a consultant, right? So to solve this problem, I'm giving you these two pieces of information. You need to tell me, one, yes, using statement one alone. So you'll get a question, incomplete information followed by two statements, statement one and statement two. So you need to tell like a consultant, yes, I can answer this question using statement one alone. I don't need two. Yes, I can answer this question using statement two alone. One won't work. Option three, third option. To answer this question, I need both pieces of information. I need one also and two also. Option four, both individually are enough. One alone I can do, two alone I can do. Option five, this question cannot be answered using both information. Right? So that is what this question type is. So given this format that you need to choose a question and two statements, is the answer 1, 2, 3, 4 or 5. One alone, not two, two alone, not one, both together, both alone or nothing. Let's solve a few questions. Let's look at this question. Pause the video here. Take a look at this question. We discussed a concept, slightly before. Use the same concept to say how this question can be answered. Right. Now, in the previous video, we discussed that when you read every question first, you have to read it without putting pen on paper. And then you have to figure out, what do I have and what do I need? So what do I have here? I know that I have X number of, say, what you call the average number of years of experience of a female of 9.8 years for males and 9.1 years for females. So we know that what is the ratio of number of males to females. So here we know the two categories are what? Males to females. Let's take the number of males as X and the number of females as Y, because you don't know that number. You know that average experience here is 9.8. Average experience here is what? 9.1. They're asking you for ratio of male to female. Right? Now let's go to the information. Right? They're asking you for, you don't know what is C. You don't know what's the average of the group. Right? That you don't know. First one. There are 52 males. Now, first piece of information says everything remains the same, 52 males. Now, what do you know? M by F, right, or X by Y is equal to, this C will be greater than 9.1 and C will be less than 9.8. So, this difference by this difference from 9.1 to difference from 9.8. Then you can get M by F or X by Y, you can get that ratio, right? But you don't know C, right? You don't know Y. Can you calculate X by Y? Not possible. So only with statement 1, you need males is to females. You're only getting number of males. You don't know the number of females. You don't know the resultant. So you cannot calculate anything. So using statement 1 alone, you cannot do anything. Let's look at statement 2. The average number of years of experience of both males and females together. So if we're clubbing them, then as a group, the experience is 9.3. Now what do we know? Same information, X I don't know, Y I don't know, number of males and number of females, but I know that the average of the group is how much? 9.3. What do we learn in the weighted average concept? X by Y is equal to this difference by this difference. So difference between 9.3 and 9.1 is how much? 0.2. Difference between 9.8 and 9.3 is how much? 0.5. So this difference by this difference, we definitely know that is X point Y. So before you calculate this, you know that to calculate X by Y, all you need to know is this difference and this difference, right? So you have that number. So what is the beauty of data sufficiency? You don't need to calculate. All you need to say is that, do I have the information to calculate? Using statement 2, I'm getting the resultant value. So once I know the resultant value, I know X by Y is equal to this difference by this difference, and X by Y is what they're asking for, right? You don't need to calculate the answer, but even if they're asking, it will be what? The difference between, say, females and the whole group average is what? 0.2. The difference between males and the group average is what? 0.5. The ratio is 2:5, but that's not the answer. Answer is this. Statement 2 alone is sufficient, right? Using statement 2 alone, you can solve. Right? So that's the answer. Let's go to the next question. A contractor mixed X tons of gravel that contained 10% gravel by weight with Y tons of mixture that contained 2% gravel, like mill percentage, to produce Z tons of mixture that was 5% gravel by weight. What is the value of X? X tons of something, Y tons of something, 10%, 2% and 5% is the resultant. What's the value of X? Right. Now, what do you know? Always write down, imagine, what do you have? X kgs of something at 10%, Y tons of something at 2%, resultant at 5%. That means before you start the question only, what do you know? This is 3, this is 5. You know X by Y is what? 3 by 5. Can you answer the question using 1 alone? What do you already have? X by Y. What is statement 1 giving? Y. You know X by Y. Statement 1 is giving you Y. Can you calculate X? Definitely you can calculate X. So statement 1 is sufficient. Right. Now look at statement 2. Now tell me whether you can calculate X. In statement 2, they are giving you the value of Z. What is Z? Z is the total of X and Y together. X tons of this, Y tons of this, together is getting Z tons of this. So if you know the total and the ratio of X is to Y, then you can calculate X and calculate Y, right? So Z is equal to X plus 5, which is 16 tons. X by Y is 3 by 5. So if it's 3 by 5, you can calculate the value of X. Again, DS, because I'm showing you the solution, I'm just explaining a bit more and giving you the answer, but you don't need that. You don't need to calculate. You know I have the total of two values. You know the ratio in which the two values are there. You can easily calculate that. So even this individually, 2 alone will give. 1 alone and 2 alone, both statements individually are sufficient, means the answer on this one is option D. Now let's look at the next question. Each employee in a company is either a director or a manager. What percentage of the company's employees are directors? There are only two kinds of employees, directors and managers. What percentage of the company's employees are directors? Statement 1, statement 2. Pause the video and solve the question. Now, what are they saying? Every person is either a director or manager. That means all weighted average situations have two groups. Section A, Section B, males, females. Here they're saying managers, directors. And what is the attribute? If in the question, they're not telling you what attribute is getting mixed. Average weight, average class, milk concentration, nothing. Once you go to the statement, you're coming to know that the thing that is getting mixed with these two groups is the average salary, right? So average salary of managers is 5 less than the average salary of all employees. It is 5 less than the resultant, the average of the entire group. So this much you know from this. Managers, directors. I don't know manager's salary. I don't know director's salary. I don't know the average salary. But all I know from statement 1, what do I know? That salary of managers is 5K less than the average. That is what I know. What percentage of the company's employees are directors? Can I calculate the ratio of MS to D from this? No. I have one difference, 5K. I know that M is to D is equal to difference from between B and C divided and difference between A and C. I have A and C, I don't have B and C, so I cannot get the average of M is to D. Now I take the next problem. Second statement is saying average salary of directors is 15,000 greater than the average of all employees. So if I look at directors, if the average is C, B is 15K more than that. From statement 2 alone, can I calculate M is to D? No, because I have this difference, but I don't have the first difference. But if I use both statements together, then what do I know? Then I know that M is to D is equal to 3:1. M is to D is the difference, this difference by this difference, 15K by 5K, that is nothing but 3:1. If M is to D, managers is to directors is 15K by 5K or 3:1, that means what is the percentage of directors? Directors is 1, M is 3, D is 4, that means total is 4, 1:4, 25%. I still don't need to calculate that, but I'm just showing you that. Now this problem, before I taught this concept, when I gave it to the students have taken an entire page to write equations and solve this, because they solve this whole thing using equations, right? But if you know this, and if you understand it in principle, you clearly know that M is to D is equal to this difference by this difference. One statement is giving you this, the other statement is giving you this, right? So both statements together can answer this question. Both statements are required. So the answer for this one is option C. Question 4. This is not a DS question, it's a normal what you call problem solving question. Spurge bought 225 pens on Monday. On Tuesday, he bought 150 more pens on Monday, how much price did he buy for? We don't know. On Tuesday, he bought 150 more pens at 6.05 per pen. Due to this, the total average of the price per pen turned out to be 22.5. What is the average price of pens bought on Monday? So, do you know that 225 pens on Monday? So, if you want, pause the video here and solve this. Now, how do we solve this? 225 pens on Monday, 150 pens on Tuesday. 150 pens were bought at what? 6.05. Total average is what? 22.5. They're asking you what is the average price of pens bought on Monday. So you know that this difference is 16.20. This part you do not know. So you know that 225 by 150 is equal to this difference, 1620, and the other difference. So by this difference, right? So we clearly know that 225 by 150 is equal to 16.20 by x, 3 by 2 is equal to 16.20 by x, or x is equal to 18.20. So x is equal to 18.20. Average is 22.5. One value is 6.05, right? And that is less than the average. That means the other value will be greater than the average. So if this is 22.5, other value is greater than the average, and distance is 10.80. What is that value? 22.5 plus 10.80. How much is that? 33.05. Yeah. So that's your answer for this. Now, this is the log method. If you same thing you solve faster and with respect to this thing, how would have I processed this whole thing? I would have straight away known that this 225 to 150 is what? 15, what you call 3s to 2. 75 3s are and 75 2s are. So I would also know that this gap is very easy to calculate. 22.25 and 6.05. I'm looking at this average is what? 16.20, right? So if this is 3 by 3, if this ratio is 3 by 2, right? This what you call Monday to Tuesday, then the difference will be in the ratio 2 by 3. So I know that this difference will be in the ratio 2 by 3. So 2 by 3 into 16.0. 2 by 3 into 16.20 is how much? 3 goes 5.4 times. 5.4 into 2 is 10.8, and I add 10.8, 33.05. Is this? This is 3 by 2 times this. Monday is 3 by 2 times Tuesday. That means this difference will be 2 by 3 times this difference. So this difference is 16.20. So this will be 2 by 3 times that. Sir, why did you do this 2 by 3 times? It's fairly simple, no? 3 by 2 is equal to 16.20 by this. So what is this? If it goes here, it goes here, it will become 2 by 3 times. So if this is 3 by 2 times this will be 2 by 3 times this. So that's how you solve this one. The answer, 33.05. Question number 5. Take a look at this question. Simple problem solving question. Solve this. Solution A contains 10% alcohol. This is 10%. So you know that this is an alcohol situation. Solution A, solution B, this is 10% alcohol. Solution B, they have not given the percentage. They have said 9 liters. Okay. When the two solutions are mixed, resultant is how much? 12. If the volume of solution B is 1/3 the volume of solution A, then what is the combined volume of the resultant mixture, right? So the best way to solve this, if you really know this concept, how will you solve this? 10%, 12%. This is volume of solution A. Solution B is 1/3 the volume of solution A. B is 1/3 A, means A is how much? 3 times B, right? A is 3 times B. 3 is to 1. This is 10, this is 12. If this gap is 2 and this is 3 times this gap will be 3 times this gap. So if this is 2, this will become 6. This is 12, this is 10, this is less than the average. So this has to be greater than the average. This difference is 6. 12 plus 6 will be how much? 18. 18% volume, by alcohol is solution B. And 18% volume by alcohol, and it is how many liters of alcohol is it? 9. So 18 by x into 100, 18 by 100 into x, that is equal to 9 liters of alcohol. 9 goes 2 times, 2 goes 50 times, that goes that side. So liter B is 50 liters. A is 3 times that, 150. Total is 200. But just to show you the whole thing, A 10%, B 12%, so resultant 12%. A is 3 times of B. B is 1/3 of A, means A is 3 times of B. That's 3:1. This gap is 2. This is 3 times this. That means this difference is 3 times this difference. This is 6. 10 is less than the average. So other one has to be greater than the average. 18. So 18% is 9 liters. That means what? 1 liter is 2%. If 1 liter is 2%, 100% is 50 liters. So if that is 50 liters, 3 times that is 150. 50 plus 150 is 200. So the answer to this one, 200. What is a way to approach math? First is start by mastering arithmetic. Arithmetic is the most important thing for CAT Quant. So arithmetic, start by mastering that. Look at concepts, not topics. What do I mean by concepts, not topic? If you think about arithmetic, they will say about profit loss, simple interest, compound interest, time speed distance, work pipe systems and everything. But that is if you talk topics. But actually, what are the only concepts? Every topic in arithmetic is only one of the three. Ratio, average, weighted averages. Time speed distance, ratio, speed equal to distance by time, and that is the only concept that is there. Profit loss, what is profit percent? Profit by cost into 100. You put X rupees, what percentage did you get in return, right? What I got divided by what I have into 100. So that is also a rate only. There is no concept, because how much did I gain on how much money I put in, right? So if you want to do any other work pipe systems, like any topic, interest, what is interest? Same thing, I put 100 rupees, how much did I get? What I got divided by how much did I put into 100. So every single thing essentially is rate or average or weighted average. Between these three concepts, all topics are covered. So focus on things more conceptually and try to understand it from that angle rather than topics, because if you try to understand topics, it will seem like way too many topics, right? The number of concepts core concepts you need to know are far fewer than you imagine. You think maths is a huge thing, but let me keep it very simple, right? In number systems, what do you need to learn? Factors and multiples, which means what? HCM, LCM, HCF, LCM, how to factorize and maximum number of factors. 4 concepts, that's it. In arithmetic, I said ratios, averages, weighted averages. You need to fundamentally understand, how these things work, right? Next thing is what? In geometry, you have lines, which is parallel lines and other things, angles, triangles, those 3 things, and a few things of quadrilateral So it might seem like angle, triangle, there are quite a few, sir, you are making it very simple, there are many to one. But finally, out of these 4, the number of formulas and other things you need to remember in principle is a very, very, for example, area of square is a square, because both sides are equal. Rectangle is length into breadth because both sides are different, right? So if you simplify it, the whole total number of formulas is not that much, right? Now, once these 3 are, it's left algebra, linear equations and quadratic equations, only 2. Understand it from a core concept, this thing, and don't make it topics. Next thing, understand the concept for what it is, something alive. Now, this is very, very important. The moment there is a concept, you kill the concept, you make it dead, as if it is something which is just there for to be mucked up. Right? Give you a story to end this, because it's very important to look at this perspective. As I said, in the All About Specializations video, I had joined the Aditya Birla group from campus, and then along with me, there were around 32 people who were management trainees, and there was one more, there were quite a few people. In the first job, usually people get very, very quickly dissatisfied with the job. They're always looking around for another job and change and everything. So one of the group trainees, he had gone for an interview. He came back, and after the interview, outside the interview place, he called me and he said, Tony, they asked me what is the relationship between interest rate and inflation. What is the relationship? Directly proportional, inversely, kaisa hai? And I was really shocked. I'm like, you're an MBA and you don't know the relationship between interest rate and inflation. How is it possible? right? It's like, it's the most basic thing. And once you understand that concept, you can never forget it for life, right? You've made it like something dead, something like a formula. So once you truly understand something, you will never, need this thing to reverse. And that interest rate inflation is a very simple thing. What is inflation? Prices increasing. Why do prices increase? Too much money chasing too few goods, right? Everybody has lots of money to buy apartments. Everybody's chasing after apartments. Then what happens? The price of the apartment will go up, right? So too few goods. Suppose there are enough and more apartments, and the supply is huge, and then even if the demand is huge, the price will not increase. But if there is too much money chasing too few goods, it's the most simplest thing. Too much money chasing too few goods, you have inflation, right? Now, what is interest rate? Interest rate is what governs money, whether money goes up or money goes down, right? Now, if interest rate is very low, bank has reduced the interest rate for housing loan. What does that mean? Everybody will go take a loan. That means there is too much money. If there is too much money, chasing too few goods, the prices will go up, inflation go up. So the moment interest rate goes down, there is too much money. That means inflation will go up because too much money chasing too few goods, right? So we know it's inversely proportional, right? It's always inversely proportional. If interest rate goes up, inflation will go down because nobody will be taking loans. If interest rate goes down, inflation will go up because everybody will be taking loans. There is a lot of money in the system. Now, my friend is an MBA, right? Did a course, but nobody really tried to understand it. He didn't really try to understand it. So my whole point is, when students come to me and say, sir, I need to revise. How, if you do not understand, do you think you need to revise the formula for profit percentage? This thing, for instance, this thing? No. If you understand something, you shouldn't. What happens is we conflate topic with concepts, right? Instead of focusing on concepts, we make a list of topics, escalator problems, this, that. What is worse is we conflate memorizing with understanding. They're two separate things. You can memorize interest rate, inflation are indirectly proportional, inversely proportional, or once you understand what it is, you will never forget it, right? So this is, till so far, we do everything for only an outcome, not for this thing. So if I get this exam, I will get it to a college. If I do this, I will get this. Not for something in itself, not because I like something. There are some people who really do it. I'm not saying that. But bulk of us do, behave that way, right? So I would say, for the first time, change that, right? Change that, because there are a few reasons, and changing that will take time. So far I'm used to just memorizing. Developing any muscle, mental or physical, it will ache. 1 week you don't work out, or 2 weeks you don't work out. After that you go and you do legs, it will ache. So anytime you're trying to really understand something and put in effort, it will hurt, but it will be worth it. You need a strong understanding of basic math, not only to crack CAT. We think, if I learn this, then I'll crack CAT and then it's over. But it's actually, the story is not over. You will need it to successfully complete your MBA curriculum. In that first year common, you have 2 math subjects and 2 finance subjects. For both of that, your understanding of math is very, very important. So if you don't do that, you will actually go on campus and you might fail and you might get kicked out of campus, right? So don't treat this as one more that it is not important in general. It is only for MBA that I'm doing. No, even for an MBA, maths is important. Most importantly, after your MBA, if you want to get into the line of business, if you're into business and you don't know math, I'm not saying that geometry formulas are important, but math, the logical reasoning with respect to arithmetic, is absolutely essential. So please do not treat this as doing it for once, right? For once, treat this as if you're doing it for life. And that is when you will really understand something. I hope this Learning to Learn Math video was useful, and you take this approach when you're actually learning these concepts on your own, or when a teacher is teaching you. And your math gets better after this. The video following this is the elegant solution, which is the third part. The first part is technique to solve any question. Second part is learning how to learn. And last part is, once you have this, how to execute elegant solutions and shortcuts. So that's the third video. So hope you enjoyed this. Thank you.